Welcome to the DIY Honda Garage channel. This presentation focuses on diagnosing the DTC P0137, which indicates a low voltage condition in the secondary heated oxygen sensor, HO2S, circuit. The term HO2S refers to a heated oxygen sensor that monitors the oxygen levels in the exhaust. The sensor 2 location is typically found in the exhaust system, downstream of the catalytic converter. Its role is crucial as it assists in assessing the efficiency of the catalytic converter and ensuring optimal emissions control. By monitoring the oxygen levels, the engine control module, ECM, can adjust the air-fuel mixture, leading to enhanced vehicle performance and reduced emissions. The understanding of this code is essential for proper diagnostics and repair. The P0137 error code refers specifically to the secondary heated oxygen sensor, HO2S circuit, which indicates a low voltage condition. The secondary HO2S is vital for assessing the performance of the catalytic converter, positioned downstream in the exhaust system. Its function is to relay information to the engine control module, ECM, about the oxygen content in the exhaust gases after they have passed through the converter. By doing this, it helps the ECM optimize the air-fuel mixture for combustion, leading to improved efficiency and lower emissions. When this sensor reports a reading that falls below 0.29 volts, it triggers the P0137 code, suggesting that there could be an issue with the sensor, the wiring, or the ECM itself. Several factors may contribute to the P0137 error. A faulty secondary HO2S may lead to incorrect voltage readings, causing the ECM to trigger the error code. Wiring issues, such as breaks or shorts in the circuit between the HO2S and the ECM, can also result in low voltage conditions, impeding proper sensor function. Additionally, loose or corroded electrical connections at either the secondary HO2S or the ECM could interrupt the necessary signals that help the ECM manage the engine's air-fuel mixture. Understanding these potential causes is vital for a thorough diagnostic approach to resolve the code effectively. The P0137 code may manifest through several noticeable symptoms. One of the most common indicators is illumination of the check engine light, alerting the driver to a potential issue with the vehicle's emissions system. Poor fuel economy can also be a side effect, as the ECM may struggle to adjust the air-fuel mixture appropriately without accurate data from the secondary HO2S. In addition, an increase in harmful emissions might occur, leading to potential failures in emissions testing. Recognizing these symptoms early can aid in prompt diagnosis and repairs, ultimately preserving vehicle performance and environmental standards. The troubleshooting process begins with turning the ignition switch to the on/to position to enable the vehicle's onboard diagnostics. Use the Honda Diagnostic System, HDS, to clear the DTC from the system's memory. Starting the engine and holding it at 3,000 RPM without a load is important. This allows for sufficient operational conditions to test the system. The engine should be in either park or neutral for automatic transmission, AT, or in neutral for manual transmission, MT. This step aims to generate normal operating conditions where the vehicle's systems can be assessed and to ensure that the radiator fan engages, signaling that the engine is reaching appropriate temperatures. It sets the stage for reliable voltage readings from the downstream oxygen sensor. The next step involves using the HDS to check the voltage output of the secondary HO2S, designated S2 in the data list. At this stage, It is crucial to determine if the voltage stays at or below 0.29 volts. If the reading falls within this range, which indicates a consistent low voltage reading, you will proceed to the next step in the troubleshooting sequence. Conversely, if the voltage exceeds this threshold, it implies an intermittent failure, at which point it is vital to inspect connections and terminals for any looseness or corrosion. This step is significant because achieving a stable low voltage reading helps in concluding whether the secondary HO2S is likely to be at fault or if further investigation is needed elsewhere in the electrical system. In this step, turn the ignition switch to the lock 0 position to ensure safety when working with electrical connectors. Once safely locked, you should disconnect the 4P connector of the secondary HO2S, effectively isolating the sensor for further testing. After disconnecting, turn the ignition switch back to the on 2 position and again use the HDS to check the voltage of HO2S S2. Like before, assess whether the voltage remains at or below 0.29 volts. This check allows you to determine if the issue is inherently with the sensor or possibly elsewhere, considering now that the sensor is disconnected. This step is essential for isolating the problem and narrowing down the potential causes. After testing the voltage with the secondary HO2S disconnected, the next logical step is to evaluate the reading once again. If the voltage still registers at or below the 0.29 volts threshold, you'll progress to step 9, solidifying the notion that the circuit up to this point is functioning correctly. However, if the voltage does exceed this value, it signifies a need for further investigation into the system to identify issues, prompting a move to step 13. The continuity tool in this process may lead you to explore wiring or terminal issues further, ensuring a comprehensive approach to diagnosing the P0137 DTC effectively. Once the previous step is completed, turn the ignition switch to the lock 0 position again for safety. Now, jump the SCS service check signal line using the HDS to enable special diagnostic functions. After this, the next action is to disconnect the ECM engine control module or PCM powertrain control module connector C, which consists of 44 pins. This disconnection is fundamental as it allows you to isolate the connections, making it easier to check for continuity tests between the components. This step emphasizes direct engagement with the control module and aligns with thorough diagnostics that may highlight any internal issues within the module itself. At this point, the focus shifts to checking for continuity between terminal number 1 at the secondary HO2S 4P connector and the vehicle's body ground. Using a multimeter, you will verify if a complete circuit exists. This process is critical for ensuring that the wiring is intact and that there's no short circuit present, which could impede the function of the HO2S and cause the P0137 error. If continuity is confirmed, you should proceed to repair any identified shorts in the wiring between the ECM PCM and the secondary HO2S sensor. On the other hand, if continuity isn't present, it indicates further investigation is needed upstream or within the ECM itself, leading you to the next steps in the diagnostic process. If continuity checks indicate issues, or if you haven't confirmed it, the likely step is to replace the secondary HO2S. Before doing so, turn the ignition switch to the lock 0 position for safety. Replacing the secondary HO2S is critical if it is determined to be the root cause of the low voltage condition. After installation, it is important to properly reconnect all the electrical connectors to avoid any new faults, clear any error codes, and check the new sensor's function closely, ensuring proper installation for reliable performance. Completing these steps effectively resolves the DTC P0137 and restores the vehicle's emissions control function. The final step in resolving the DTC P0137 requires you to turn the ignition switch to the on-2 position to power the vehicle's electronics. Next, utilize the HDS to reset the ECM or PCM settings to clear any previous fault codes. This reset is crucial to ensure that the new readings from the HO2S are established without interference from prior history. A thorough inspection should follow, where you monitor the vehicle to confirm that no DTCs reappear following the replacement or repairs made. This verification ensures both that the repairs have alleviated the low voltage issue and that the sensor operates within its expected parameters. To prevent future occurrences of the DTC P0137, it is advantageous to instill regular preventive maintenance practices. Regular inspection of electrical connections related to the secondary HO2S is key. Ensuring they are tight and free from corrosion can extend the component's life. Additionally, periodically checking the integrity of the wiring for any signs of wear or damage can help prevent shorts or opens in the circuit. Engaging in routine diagnostics on your vehicle will also provide early detection of potential issues before they escalate into more significant problems. Taking these steps promotes the reliability of the emission system and enhances overall vehicle performance. In conclusion, understanding the DTC P0137 is essential for effectively diagnosing issues related to the secondary HO2S circuit. Each step of the diagnostic process, from obtaining freeze frame data to checking continuity, plays a crucial role in pinpointing the root cause of the error code. Correct diagnosis can lead to timely repairs, ensuring that the vehicle operates within emission standards and performs optimally. Emphasizing preventive maintenance practices helps in mitigating potential future occurrences of similar errors, thereby enhancing the longevity and efficiency of the vehicle's emissions control system. Being proactive in both diagnosis and maintenance leads to a smoother and more reliable engine performance overall. Please like and subscribe to the channel. See you next time!